Hydrogen bonding. Hydrogen bonding, as the name indicates, is a type of bonding in which hydrogen atom is involved. Hydrogen bonding is not any bond, but yes, it's a force, it's an intermolecular force that is present between the molecules. Here we have oxygen. Oxygen is electronegative in nature. Here we have these two hydrogen. Now in this hydrogen and in this oxygen, a bond is present, and that bond is a covalent bond because here we have mutual sharing of these electrons, and the electronegativity of oxygen is very high as compared to this hydrogen. Due to that electronegativity difference, oxygen got a partial negative charge and this hydrogen got a partial positive charge. And same goes for another water molecule. Now this molecule also has partial positive and partial negative, and the other molecule also has partial negative and partial positive end. Now partial positive end of one molecule and partial negative end of the other molecule start attracting each other. There is a force of attraction between them, and that specific force of attraction is an intermolecular force, and mainly when it is between a hydrogen atom and a highly electronegative atom, this kind of force is called as hydrogen bonding. What is the hydrogen bonding? As we just discussed, hydrogen bonding is a special kind of dipole-dipole interaction that occurs between a hydrogen atom that is bonded by a highly electronegative atom, and this is actually the condition of hydrogen bonding. There are other intermolecular forces also, but the specialty of hydrogen bonding is in hydrogen bonding, there is always one hydrogen, and that hydrogen is bonded with a highly electronegative atom. Here we have some examples of hydrogen bonding. Here you can see that fluorine, having the highest value of electronegativity, forms the strongest hydrogen bond. We all know that fluorine is highly electronegative element in the periodic table. One hydrogen and fluorine will make a covalent bond. In that covalent bond, the fluorine is much more electronegative as compared to hydrogen, and as a result their electronegativity difference is also very high. Due to high electronegativity difference, as a result a partial positive charge and a partial negative charge comes here. Due to these partial positive and partial negative charge on another molecule also, the partial positive charge of this molecule and the partial negative charge of this molecule start attracting each other, and due to this attraction, as a result what happens, a force generates, an intermolecular force generate, and that intermolecular force is specially called as hydrogen bonding. A water molecule also contains a highly electronegative oxygen atom which is linked to the hydrogen atom. Here water molecule is the famous example of hydrogen bonding, in which here we have a water molecule and here we have another water molecule. Now what happens here, as this is a covalent bond, due to that we have mutual sharing of electrons, and oxygen is more electronegative as compared to hydrogen. Now this shared pair of electron is dragged more towards the oxygen just because of its more electronegativity. Then what happens? Oxygen got a partial negative charge and this hydrogen got a partial positive charge. Now partial positive charge of one molecule and partial negative charge of the other molecule, they start attracting each other. When they start attracting each other, intermolecular force generate between them, and that intermolecular force is specially called as hydrogen bonding because in this one a hydrogen atom is involved. Now a question arises here, do all the molecules which have hydrogen, do they have hydrogen bonding also? No, not at all. As we discussed earlier, that hydrogen bonding is always in those kind of molecules in which we have a highly electronegative atom. If we have a highly electronegative atom with hydrogen, in that case we will observe hydrogen bonding in the molecules. Say for example we have HCl here. In HCl there is no hydrogen bonding because the electronegativity difference of this hydrogen and chlorine is not high. That is why there is no hydrogen bonding in hydrogen chloride. Say, for example, if we have any organic molecule, it doesn't mean that it has hydrogen bonding, because now this time the electronegativity difference between carbon and hydrogen is very low. Due to this very low electronegativity difference, there is no hydrogen bond in organic molecules. Now, I have a trick for you that helps you to memorize in which kind of molecules we have hydrogen bond. If we have fluorine and hydrogen together, and if we have oxygen and hydrogen together, and if we have ammonia and hydrogen together, in that case we will observe hydrogen bonding in the molecules. Types of hydrogen bonding. Here we have two types of hydrogen bonding: intermolecular hydrogen bonding and intramolecular hydrogen bonding. Intermolecular, as the name indicates here, intermolecular hydrogen bonding is the one that is in the molecules. Now, when hydrogen bonding takes place between different molecules of the same or different compound, this type of bonding is intermolecular hydrogen bonding. Intramolecular hydrogen bonding. The hydrogen bonding which take place within a molecule itself is actually called as intramolecular. Intramolecular means inside. Say, for example, here if I have this water, now what happens that this hydrogen makes a bond between this oxygen, and this hydrogen also makes a bond with this oxygen. Now the bonding of this hydrogen with this oxygen is inside the molecule. So that is why this bonding is called as intramolecular hydrogen bonding. We have two types of hydrogen bonding. One is intermolecular and the other one is the intramolecular. Intermolecular hydrogen bonding is between the molecules, and intramolecular hydrogen bonding is inside the molecules. So this is the difference between both of the types of hydrogen bonding. Hydrogen bonding have high melting and boiling points. Compounds having hydrogen bonding show abnormally high melting and boiling point. Say, for example, here we have water and here we have hydrogen sulfide. Now a question arises here, why water has a high boiling point as compared to hydrogen sulfide? The answer is very simple. Because in the case of water, the molecules have hydrogen bonding, but on the other side, this hydrogen sulfide is here. In the hydrogen sulfide, there is no hydrogen bonding. If there is no hydrogen bonding, so this makes a difference here. That is why water has high boiling and melting point as compared to this hydrogen sulfide, and hydrogen bonding is the main reason behind this. So yes, this is all about our today's lesson. If you want more such videos, please don't forget to subscribe. Thank you very much.